ladies and gentlemen, this is Mr. Green. I just wanted to make this recording for you because I am giving STAR tests this week to the younger grades. Not to you all, not to high school students, it's to younger grades. So don't worry, I just can't be available for Class Connect. I will be here next week and we will review heavily for the STAR test next week. But this week you're taking or you probably already have taken the Unit 6 test because that was uh, on Monday scheduled to be done. But I wanted to give you a little bit of a review in case you didn't have it done yet. You can go back and look at it and see what we got. So this graph shows the system of y equals x plus 2 and y equals 3 minus x. How many solutions exist for this set? And I want you to notice, here's one line. Come on. Here's one line right here in green. Here's another line right here. And the place where they intersect is their solution. So how many solutions for this set? Just one. There's only one. It's a point. You would write it as an x, y coordinate point. Easy enough to do. Okay? This graph shows the system 3x plus 6 equals 18 and y plus 2y equals 6. What's the solution set for this system? Well, in this particular system, I only see one line down there. So I have to ask myself what's going on. So I'm going to take this 3x plus 6y equals 18, and I notice that all three of these are divisible by 3. So I'm going to divide every one of them by 3, factoring that out. Okay? When I do that, I get x plus 2y equals 6. That is the exact same equation as I've got on this one over here. So that means this one line represents both equations. So there is infinite number of solutions for this one. An infinite number of solutions because it's the same line. This one, how many solutions exist for these two systems? Y equals 3x minus 1 and y equals 3x plus 3. Well, in this particular one, I happen to notice that the slopes were the same on this. This one's got a slope of 3 and this one's got a slope of 3. That means they're parallel lines. I've got this blue line here and I've got this green line here. Parallel, never touching. There are no solutions for this one because unless they hit each other, unless they touch each other, there won't be a solution. Okay? That's the way you do those type of problems. Now, what point is the solution to this system? Okay? There are 3 methods for doing it. First one we covered 2 weeks ago was called graphing. The one we covered last week was called substitution. Well, we actually covered those two both 2 weeks ago. Graphing and substitution. I recovered this substitution one last week and went into this one, elimination. Okay? So there's 3 different methods for doing it. I am going to show you the one that I think is the easiest to do. And since they both are y equals, I'm going to use this substitution one. I'm going to have minus 3x plus 5 is equal to 2x plus 5. Okay? So I take the smaller x, in this case the minus 3. I'm going to add 3x to both sides of this equation. And I'm going to get 5x over here, and that's going to go to 0. Okay, so I've got 5 is equal to 5x plus 5. I'm going to subtract this 5 from both sides of this equation. And I'm going to get that I get 0 is equal to 5x. That means that x is equal to 0. Divide by 5, you get that. So when x is equal to 0, I can substitute that into either one of these two equations. And what am I going to get? Y will be equal to 2 times 0 plus 5. That's 0 plus 5. That's 5. So y will be equal to 5. So the point where these two intersect is going to be at 0, 5. Okay? You can just as easily do this graphically or with elimination, but this is the way I chose to do it this time. Okay? So lots of lines on this one, and they're saying using the graph is the best estimate of an ordered pair using the graph is the best estimate of an ordered pair that is a solution set of the system y equals 3x plus 2 and y equals 1/4 x plus 1. Well, a little bit difficult to see here, so what I want to do is I want to take my highlighter here and show that this is the line that is 3x plus 2. Right there. How did I get that? Well, it's labeled right here. Okay? The other one, 1/4 x, negative 1/4 x plus 1, that's this pink line right here. Okay? And they're asking me what is the best estimate of an ordered pair here. They don't want the exact ordered pair, they want a best estimate. So they're wanting that point right there. Well, let's see here. My x value, well, it's like somewhere between 1/2 and maybe 3/4. So I'm going to say 1/2. Okay? Negative 1/2. Why is it negative 1/2? Because I went backwards 1/2 of a step there. And it's up. And it looks like it's a little bit above 1. So, wait a second. That shouldn't have been a parenthesis there. Sorry about that. Negative 1/2, comma. It's a little bit above 1. So I'm going to say, well, I'm just going to say 1. Because it looks like it's just a little bit above it. Now, it's a little bit greater than both of those, or different from both those two things, but that's a pretty close estimate to a solution to this one. So let's try it and see what we get. If I take 3 times negative 1/2 plus 2, well, 3 times negative 1/2 is negative 3 over 2, plus 2 is 4 over 2. Let's see, that's going to be equal to negative 1/2. That's not anywhere near 1, is it? Let's try it in the other one over here. So, negative 1/4 times negative 1/2 plus 1. Well, that's going to be negative times negative is a positive. I get 1 over 8 plus 1, and that's 1 and 1/8. That's pretty close to 1, so that's not too far from being this point right here. So this one's not too far from that, but this one here, it's that negative 1/2 gave me a that's a positive. I'm sorry, positive 1/2. So 1/2, it was right here. So yeah, it's a little bit off there. I guess I need to change my solution just a little bit and maybe go up just a little bit further over from 1/2 and maybe say negative 1. Well, not going to be a fourth. How about 3/8? And that might make it a little bit closer. Cool. So it's best estimate, it's a guess. So I'm guessing at this point right here. Somewhere between negative 1/2 and negative 3/8. So going on to the next slide. It says using elimination. They want me to use a specific method. That means I need to show that I use that method. So let's just write down the equations here. 2x plus y equals 8. And then the other one is x plus y equals 4. To eliminate means I need to get rid of one of the variables. So to do that, I'm actually going to subtract this whole equation from the first one. So 2x minus x would give me an x. And a y minus a y would give me a 0. I eliminated the y. And 8 minus 4 would give me a 4. I got a value for x. Now if I stick that value back in up here into this equation, x plus y equals 4. Well, 4 plus y equals 4. Subtracting 4 from both sides, y equals 0. My point that I get doing this is at 4, 0. Okay? I want to check that in the other equation over here. 2 times 4 is 8, plus 0 is 8. So it still turns out to be an 8. So yeah, it checks in that other equation. That would be my answer. Okay? This one says solve the system of equations and what's the value of x. They're not telling me how they want it solved, so it's my choice how I get to do it. Okay? Well, what I see here is I think it's going to be easy to do elimination in this situation. So x plus y equals 6, and the other equation is x minus y equals 2. Since these two have opposite signs, the x plus y and the x minus y, if I add these two equations together, I'm going to get an answer that eliminates the y's. So x plus x is 2x. Positive y plus a negative y gives me 0. 2 plus 6 is 8. So x is going to be equal to 4. Now if I plug that value back into one of the equations, 4 minus y equals 2. If I subtract a 4 from both sides of the equation, I will get a minus y is equal to negative 2. Well, they're both negatives. I need to multiply times negative 1 on both sides of the equation, and what I'll get is that y is equal to 2. My point is going to be 4, 2. That's going to be my intersection. Try it in the other equation. 4 plus 2 is 6. It worked. So that's going to be the equation, the point where they intersect. Okay. This one says solve this system of equations. Once again, they're not giving me a technique that they want me to use. So I got 3x plus 5y equals 8 and 4x minus 7y equals 10. I don't see an easy way that elimination is going to help me a whole lot here. So I like to fall back onto substitution because that is my favorite one to do. So I'm going to take the first equation, 3x minus 5y equals 8, and I'm going to add 5y to both sides of the equation. Why did I pick y? Well, it was being subtracted, and if I add it, it just seems like I'll wind up with positive numbers is the way I'm looking at it. So I get 3x is equal to 5y plus 8. Now I'm going to divide by 3 in this situation, and I'm going to get that x is equal to 5y plus 8 divided by 3. Leaving it in that form, I'm going to substitute it into this other equation over here. So 4 times 5y plus 8 divided by 3 minus 7y equals 10. Well, I need to do distributive property here. So 4 times 5 is 20y. 4 times 8 is 32. But this is still divided by 3. Is minus 7y equals 10. Okay, fractions. Don't like fractions. So if I multiply everything times a 3, and I multiply everything in here times 3, I'll get rid of that fraction. And I'll get 20y plus 32. Got rid of the fraction. Minus 21y equals 30. See how I had to multiply this one by 3 and this one by 3, but this one, the divided by 3 cancels it out, right? So, combining some like terms here, 20y minus 21y, I get a negative y plus 32 equals 30. I'm going to subtract the 32 from both sides, and I'm going to get y is equal to 2. Actually, I got negative y is equal to negative 2, but then I multiplied by negative 1 in my head, and I got y is equal to 2. I can take this value right here for y, put it right back into this, and find a value for x. So 5 times 2 plus 8 divided by 3. Well, 5 plus 2 is 10, plus 8 is 18, divided by 3 is 6. So my x value is 6. My point that I'm looking for is at 6, 2. Ta-da. Cool? Let's go on to the next one. It says the sum of two numbers is 110. Ah, this is the type of problem where they're not giving me the system of equations. I need to come up with them. And they're saying the sum of two numbers is 110. So I'm going to say one number is x, the other is y. X plus y equals 110. That wasn't easy. Or wasn't hard. Their difference is 28. X minus y equals 28. What is the smallest of the two numbers? Well, to find the smallest, I've got to find both the two numbers here. Look at the way I wrote this. It's almost leading me to do elimination. If I just add these two together, I'm going to get that 2x is equal to 128 and that x is equal to 64. Okay? I can use this 64 back in one of these two equations. 64 plus y equals 110. So y will be equal to 110 minus 64. Doing that in my head, I get a, let's see here, 10 minus 4 is a 6. And that leaves me with 10 minus 6 is a 4. So I get y is equal to 46. 46 is here. 10, carry your 1, 11. Yes, that'd be the right answer. So which one is smaller, 46 or 64? Well, 46 is the smaller one. So what's the smallest of the two numbers? 46. Ta-da. Okay, like we talked about last week, when we're looking at inequalities, you treat them just like they're equalities. Don't do anything different. Graph them the same way, solve them the same way. I've got y equals 5x minus 1. Well, that'd be this line right here that I drew. It's drawn right there. And I've got y equals 0. That would be this line right there. Okay? And you're looking for where they intersect. Well, they intersect right there at 1. So the question is, which way do I shade in each situation? What I'm going to do is, since they intersect here, 0, 0 is on one of them. I need to pick a point that's not on either line. So I'm going to pick this point right here, 1, 1. And I'm going to stick 1 and 1 into the original equations. 5 times 1 plus 1, well, that's equal to 6. Is that greater than or equal to 1? Because that was the point. X was 1, y was 1. And the answer is yes. That means I need to shade the side that has 1, 1 on it. So I'm shading this side over here. Now let's come up down here. X is equal to 1. Is 1 less than 0? No, 1 is not less than 0. So I need to shade the other side away from 1, 1. That's why the green side is shaded. Okay, now that we've shaded both those two sides, I can see that this tiny sliver down here is the only portion that is in both of them. Okay? And since it's in both areas, anything in that green area right down here would be considered in the solution set. So it says identify one of the ordered pairs that's in the solution of the system. One of the ordered pairs that would be in this solution would be that one right there. That -1, -4. Okay? Now, because these are less than or equal to, the lines are in there as well. And so you can pick anything that's on those lines. I could have said 0, -1, 0, -2. Any of those would have been on that line, would have been in that green area. Cool? Okay, one more for the review. Okay, which of the following regions is in the solution to the system y greater than x plus 3 and y less than -x plus 1? So I need to determine the shaded regions is what I need to determine. So I can see that this point down here, my favorite point, 0, 0, is not in, it's not on either one of the two lines. So I'm going to stick 0, 0 in for x and y here. 0 greater than 3? Well, the answer is yes. And so I need to shade that side of that line. And that would be everything down in this region down here like this. Okay? How did I know that this was that line right there? Well, it goes through point 3, has a slope of 1. So that was that line right there. Okay, so going back to this, sticking 0, 0 into for x and y here, what do I get? 0 is less than 1. Well, that's true too. So I want to shade that side of this line. Okay? I want to shade the side of that line that has 0, 0 in it. Well, the side of that line that has 0, 0 in it is this side down here. Okay. So, in other words, where do the shaded regions overlap? Well, the shaded regions overlap down here in C. C would be my answer at this situation. Do you see how I did that? By picking a point not on the lines that I can stick in there and determine which side of the lines to shade. Sometimes you get a yes, sometimes you get a no. If you get a yes, you shade that side of the line where the point is. If you get a no, you shade the other side. Okay, well that's enough of a review of Unit 6. You need to make certain that if you haven't taken that Unit 6 exam, please go take it right now. Get it taken care of for me, okay? What I want to do is go on to the next unit, which is, we only got one lesson in this whole unit, and it talks about direct variation. It's actually going to talk about direct and indirect variation. But a direct variation is something where they both go up, or they're directly proportional to each other. They both change at the same rate. Okay? They both have that same constant rate. So as you get older, you get taller. The relationship is called a linear relationship. Okay? The x and the y intercepts on this are always going to be at 0, 0. Okay? And there's a simple little equation. This equation right there that you will use on all direct variations. Okay? So let's look at another one. An inverse variation. Inverse variation means that they change opposite of each other. That means as one increases, the other decreases. As one increases, the other decreases. The faster you drive, the shorter the trip. The relationship is not considered linear at all. It is considered inverse. Okay? So what you do in this situation is you say y equals k divided by x. That would be the equation we'll use here. Okay? So let's try a couple of these. Okay, which one of these is a direct variation? Direct variations, linear. That means it's this one down here, direct. It's a straight line. Okay? Oops, go back to this. Which one is an indirect variation? Well, this one up here is indirect. Because as one's going up, as x is getting bigger, y is getting smaller. As x is getting bigger negatively, y is getting smaller negatively. This one is quadratic. It is neither direct nor indirect. Cool. Okay, this is what most of the problems you're going to see look like. It says assume that y varies inversely as x. Well, inversely means that we use this equation. Y equals k divided by x. Okay? They say if y equals -6 and x equals -2. Well, you can come down to this equation. You can stick in there. -6 equals k divided by -2. Multiply through by that -2, and I'm going to get a 12 is equal to k. Now I can come back here and say that y equals 12 divided by x. For this problem, this equation is what we just developed. And they said find y when x is equal to 5. So y will be equal to 12 divided by 5. That's all you have to do. It really is easy, but a lot of people miss this. It becomes very difficult for them to understand. Okay? Let's try a couple more. It says, use the law of levers to solve the following rectangle. A rectangle has a width of 22 inches and a length of 18 inches. Find the length of another rectangle of equal area if the width is 20 inches. Well, the relationship here is called an inverse relationship. This law of levers that they're talking about here, we don't talk about it in our course that much, but what it is the inverse relationship. Okay? So we're going to say y equals k over x, and they're giving me that the width is 22 and the length is 18. So let's see here. Which one do we want to put them into? I'd say let's put 18 here is equal to k divided by 22. So when I multiply through by the 22, I'm going to get 18 times 22 is equal to k. Okay? So that means I need to multiply that out. I got my handy dandy calculator out. 18 times 22 is equal to 396. So that means, going back to my original equation, 396 is what k is. And so what I'm going to do here is write my original equation, y equals 396 divided by x. Okay? Now, what was this x and y? The way I wrote this, the x was the length and the y is the width. So what we're going to do is we're going to say that the length is equal to 396 divided by the width. Okay, they want one that's of equal area when the width is 20 inches. So the length will be equal to 396 divided by 20. Let's see here if I can do this in my head. 396 divided by 20 is 19.8. So my length in this situation is equal to 19.8. Cool? Good. I'm glad you're seeing how that looks. Okay. Another question you might see. If you're given an inverse variation equation, xy equals 10, complete the statement. Let's see here. Y, okay, that means y is going to be equal to 10 divided by x. So as y is getting bigger, x has to be getting smaller. So y increases, nope, y decreases as x increases. So y decreases as x increases. So the bigger x gets, the smaller y gets. Okay? So, those are rational equations. We get to that next week. We get to that after. Yeah, we get to that next week. We're not going to worry about it. So, based upon what I've done so far, I hope you're looking at this and going, I am totally understanding the way system of equations are solved. And my windshield over here is perfectly clear for system of equations. Direct variations, indirect might be a little bit buggy, but you'll get to work some problems on those and see how they worked. Okay? Okay, I want to give you just a couple of star questions here before we go any further and make certain you catch those. It says, which equation represents the graph below? One technique for solving this type of problem. They gave me four different equations here. I've got a calculator. I can press y equals and key each one of these in to it and determine which one of these it looks like. I can tell you that this one looks like this. I can tell you that this one looks like this. I can tell you this one looks like this. And that this one looks like that. So which one of these looks like the one that's drawn up there? Well, these two are the only two that are going the same direction and have the same number of humps on them. It's going to be that answer right there. I did that because I know how these work. You could do that by using your calculator to see what the graphs look like for each one of them. Okay? Here's what it says. A shipping company uses the weight of packages to determine the shipping price for any item greater than 5 pounds. The following equation gives the price of shipping an item, that's what P of W is the price based upon the weight, between two locations as a function of the item's weight in pounds. The company does not use the equation to determine prices for items which are greater than 80 pounds. The trick here is they're asking you, what is the range? Well, we need to figure out the domain here as well. My domain in this situation is going to be anything greater than 5. That means an open parenthesis and a 5. And anything less than or equal to 80. 80 is my top end, and that's where you use a closed bracket because it is included in using the equation. Greater than 80 you won't use it, but 80 you do use it. Okay, now I can take these two domain numbers in for the weight and see what I wind up with. So if I use 5, that's 3.5 times 5 plus 5.50, and I'm going to get $23 even. And then the other one is 3.5 times 80 plus 5.50, and I'm going to get 285.50. Okay, since these are the values I get out for y, or for the P of W, in both of these two cases, P of 80 in this case, and P of 5 up here. Since those are the values I get out, that tells me what my range is going to be. My range is going to be from 23 to 285.50. Those are going to be my two values. I'm going to use the same type of brackets I used up there. A curved bracket there and a solid bracket there. Okay? So this looks like this answer right here. Range and domain is something that you have to be very careful with. What we're talking about there, when we're talking about domains, we're talking about x values. Range, we're talking about y values. And all I did here was say, well, what x values does the problem tell me to use? That one and that one. And I said, well, it has to be greater than this. Greater than is a curved bracket. And this one says which are items that are greater than. They are excluded if they're greater, but 80 would be included. That's why I put the closed bracket on that one. Okay? Hopefully that helps you. These are both questions that you could see on the EOC. If you're doing nothing else this week, if you finish all the work, please make certain that you go out there and work on the study island material. Get as much of those study island questions done as you can. We want to get that up to speed as quickly as we can. Get that up to completed as high as we can, because that will help you on the test. It's getting closer. I'm giving the test to younger kids, not Algebra 1, but I'm giving other STAR tests to younger children today. But I know that you're going to do well next week. Or in 2 weeks. I will see you next week, and we will do some more review for STAR. I look forward to it. I'll see you then. Bye.